Can you please see my screen, please? Can you see my screen? Hello?
Yes, I am following
Can
up
you
with.
see my screen?
Yes,
Okay.
so I want you to start from surfaces because that's where the task was starting. So that now we proceed. Thank you.
Okay. All right. So with the surfaces, uh, you first have to get your coordinates from the surveyor, and if you have to edit it, then you go ahead to edit it. So, for example, I have these coordinates. These coordinates. I have these coordinates.
Yes.
Yes. So out of these coordinates, I developed the road surface. So the coordinates has the northings, the eastings, and the elevations, as well as the point numbers and the descriptions. So for the descriptions, I used the initials. For instance, if I have the culvert CVT for the culvert, the head wall HW, just to make it easier for you to work with them.
Yes.
In AutoCAD or Civil 3D.
Yes.
Yeah, and the default setup for the coordinates is the PENS-D, which is the points, eastings, northings, elevations, and the description. I mean, this is the order the points have to follow. So having done that, having edited
Yes.
the survey data to suit what you want, now you come to point and you create, you insert point from far. You go to point from far, or you can as well go to point and select from here as well. So you go to points, insert point from far. Point from far, you click on the plus to take you to the destination of the CSV file. Then you upload it. Having uploaded it, you come to the format, the file format. If it's the PNG or any other format you want to use, then you select it from the list. So in my case, I'm using the PNG. I select the PNG, and also if I want to create a point group, I take the box to add points to the point group. Then I will load my points in AutoCAD. Are you there, please?
Yes.
Okay. Or should I open a new page and start the whole thing for you to see?
No.
Like,
You're doing it right.
okay. Okay. All right. So having done that, having uploaded the point, you go to your settings. The settings, you click on the points, then you have the description keys. At the description keys, you right click and you go to edit keys just to edit your points. So the description as you have in the CSV or the Excel sheet is exactly the same thing you're going to do here. The code has to follow the description as you have in the Excel. So in this case, the center line, I have my center line here, and with the description, the point label style, I select the description only. because I want to see just the description attached to the points on the model space.
Yes.
Hello, just a second, please. Just 1 second, please. Engineer, please, just a moment. Just a moment. Please pardon
No
me.
problem. No problem. You let me once you're done.
Hello, engineer. Please forgive me.
No problem. No problem. Proceed.
There is this call that came through. Sorry for that. Okay,
Okay.
so I edit the point label style. So I select the description only, and also for the style, I click on the style. If I want to create a new style for my code, I just click on the drop down and I go to create new. So for the create new, I enter the new point style, the markers I want to use. I select them here. If I want the plus, the cross, or the box, circle, whatever I want. Or I can as well select from the list the default block symbols. If that is what I want, then I can go ahead and select them. The skill, I'll use the drawing skill. Then I'll go to the display. So for the display, that talks about how I want to see my labels and the marker. So I can click on the layer. If I want to create a new layer, I come to new and I create a new layer here. Then I'll go back, I'll select the color. If I want the color to be by the layer, I select it. If I want it to be by block, I select it. Then I apply the layers to the codes. So I created the root edge, a layer also for the root edge as well. So that's what I have here.
Yes.
Okay. So having created the codes, I then come to Prospector and I'll select I'll select this the point groups, and I go to, I use the same name as you did in your in your design, so that's why I'm still maintaining the name. So please don't
Yes.
worry about that. I want to use the Kenyan standard. So I go to apply description keys. So having applied the description keys, I will then see the descriptions on my drawing attached to the points. So when I've been able to create the codes for my various descriptions, then I'll come to the prospector, then I'll select the point group name, and I'll go to apply description keys just to be able to see the editing that I did on the codes. So once I've been able to edit the descriptions and everything is okay for me, then I will proceed to the creation of the surface or the surface. So with the surface, what I'll do is I go to the surface and I'll go to create surface. In the create surface, the type of surface is going to be the thin surface. And for the name of the surface, I use the existing ground to be the name of the surface. The description, the style, I use the contour 1 meter and 5 meter for the background. And also for the render material, I used the gravel, the site work planting gravel crush. That is what I use for the rendering material. So I created my surface, and this is the surface I created. That is the existing surface I created over here. So, so this is the surface I created.
Super. This looks amazing. Yeah, let's go to surface analysis now.
Okay, for the surface analysis, I click on the surface I've created and I go to surface properties. So for surface properties, I go to this is the statistics. When I come to statistics, I have my minimum and maximum X, Y, Z coordinates and the mean elevation, which is the 736.838 meters. And I have for the standard, I have the minimum slope, which is 0.17%, and the maximum slope to be 5184.58, and the mean slope to be 6.32. Apparently, I think these values are different from what you were showing. Yours, you had a mean slope to be, I think, 2.5 thereabouts or so, but I don't know why I'm having a different slope here. Perhaps
let me check against mine.
Sure.
Because I have it here. Let me see whether we end. Okay, you can proceed.
Okay. Okay. So for the surface
we actually have the same 6.32.
It's the same?
6.32. Yeah.
Okay, but I think I saw 2.5. Anyway, so with the analysis, I want to analyze the slopes. For the slopes, so the number of the ranges I want to see is 4, just 4 ranges. So I click on the arrow, then it brings me to this. I can preview it to see. So it starts from 0.167 to 4.4. So I can start with a range of 0.167 to the slope of my camber is going to be 2.5. So I can start with the 2.5, and also from the 2.5 to 10, 2.5 to 10, and from 10 to 46, and 46 to this. So I can show this, I can apply this. Okay, so I go to surfaces, display, border is not displayed here. Okay, if I want to see my slopes, I go to edit surface, And in the edge surface, I will have to activate the slope and the slope arrows and apply. Let me put up this. Okay, I want to put up the border, the edge on the. Okay. Okay, I think that the colors I used. Let me change the colors.
I'll modify that.
Yeah, let me modify the colors used. Okay, for the colors, the top one I can use red. Okay, the second one I can use blue. Okay. So this is a depiction of how the the surface is sloping.
Yes. So what do you gather from that?
So what I gather from this is that with my surface, so with the surface, what it means is that when I take from 0.167 to 2.5, I have an area of 211,809. So which means that is the largest area, and that is, I mean, a maximum percentage of the area is within the road camber limit. But
yes.
From 0.167, which means that we are looking at a minimum slope of 0.5. So anything below 0.5 would mean that there will be flooding. So which means we have to work on those areas to prevent the flooding. And also for the green, we have 2.5 to 10.7, which is more than the gradient that we are looking for. It's higher. So the red is okay. So all these areas, they are within the limits. All these areas where we have the red are within the threshold.
Yes.
So
I think we are good up to that point. So we can go to, I wanted to see your understanding on those two aspects, and I think that's very good. I see now you understand it as a workflow and not a click. That is one of the things that I try and I always want, because when you understand it as a story, as a process that you need to go through, then it becomes easy for you to even do it in other projects, which is fantastic. So we can go to horizontal alignment, then we gauge that and finish. So that now we review any questions that you have, and then we introduce the next chapter.
Okay. All right, that's fine. But for the volume computation, I don't need to do it, right?
No worries. If you got the surfaces right, then even volumes, you're fantastic.
Okay. So for the horizontal alignment, let me put this off. Let me turn this off. So display. Okay, so
Mm-hmm.
for the horizontal alignment, I go to, if I have a polyline I want to use for my horizontal alignment or for my alignment, I just have to click to draw the polyline. I draw the polyline, then I go to the alignment. I click on create alignment from object, then I click on the object. Okay, so that I go to enter. So this is the table I'm going to edit to get my alignment. So the name, I type in the name, the site, none, the alignment style. If I want to edit the style of the alignment, I can go here, edit it. And also the alignment label set, I select the major, minor, H plus V geometry and super elevation. So if the starting station, that is the chainage. Any chainage I want to start from, if I want to start from chainage 26 plus 100, I put it there. Then I come to the conversion options, add curves between tangents. I untick the box just to prevent it from adding any curves to my alignment. And the default radius, okay, once I untick it, it will also go off. So that I come to the design criteria, I input the design speed, then I click on the use criteria based design. I tick the box and select the code I want to use for my alignments. Basically, it will be 2018 roadway design standards. So then I go to the minimum radius table. I select the 2011 metric super elevation maximum of 6% per the standard, and it's a 2-lane, and I use the AASHTO 2011 crown roadway. So this is what I use to create the alignment when I have my polyline or I have my object. So the main alignment creation, I select the alignment tool, I go to alignment creation tools. Then I type in the name of the alignment, the chainage, obviously starting from 0, the site proposed, I select everything. Then I go to the design criteria, I input the design speed, which is the 80 kilometers as we selected in our last session. Then I select all the parameters. Then I untick this, the use design check sheets. As you mentioned that we will do that later, so I have to untick the box. Then I click OK to start with my road alignment. So with the alignment creation layout tools, the first one, if I want to create a straight line, this is what I'm using, the tangent to tangent with no curves. So this is my starting point. I click here. This is my starting point, and this is my end point. The end point is here, somewhere here. So the second street is also here. I click to create the second street. And having done that,
Mm-hmm.
Okay. So having created the two streets, then I go to this tool. Then I'll select the free spiral, curve spiral between the two entities, just to create the circular curves in between the streets, as well as the transition curves. So when I've been able to create on this, it will ask me to click on the first and the second and the second. Then I'll select the oh, let me use let me okay, let me just create an alignment. Just an alignment. Let's see, this is my alignment. This is the alignment. And I'll create a second alignment. This is the second alignment. This is my second alignment. So having done that, I'll go to these two. Then I'll select the first and the second alignment, which is less than the 180 degrees. Specify radius. So the radius is 350 per the code. The spiral length is 45. So this is what, so this is the circular curve. So if I want to adjust it, I use this triangle to adjust it to suit the existing good center line. So that is what I've done here. And obviously the radius is within the standard. So there is no need adjusting the super elevation. Where we have the radius going below the standard, then there is the option to adjust the super elevation. So in other words, the radius is inversely proportional to the super elevation. Once radius increases, then obviously the super elevation has to reduce. As super elevation increases, then the radius also has to reduce. So with this, my circular curves, that is within the limits of the radius. So there is no point increasing the super elevation. So the same is what I've done here. I use the same principle also here to create a circular curve and the transition curves. And I've done that also here. It's the same principle I used. But here,
Okay.
there is a bit of deviation from the center line.
Yes. So we discussed two ways of handling that.
Yes, exactly. So the first is to use this symbol for the adjustment. You can use this one to adjust. And the other thing is to also click on this, the alignment grid view. Then you can edit the radius to suit the existing center line. And that is exactly what I have done.
Okay. Okay, great. I think that's a superb presentation. Thank you. Thank you very much. I like that. I'm very, very, very impressed. I think yesterday was a good day and you made good use of it. That's yeah, yeah. Sorry.
Thank you.
Yeah, and I'm always happy to see um you understanding the basic principles. And I see, sorry, I don't know what has happened. I see that you have understood the fundamentals, the fundamental principles. Hey, sorry, I don't know what is wrong. I've eaten too much today. I think you have understood the fundamental principles and you have understood them at a deeper level. So my challenge to you is then I will give you another challenging project once we are done with this, so
Okay.
that now you see how good can you be able to apply,
Mm.
and that is what actually engineering is. Engineering sometimes is you looking at, and that's why we do benchmarking, case study, we learn from each other's, and all of those things. You learn from this experience. And when you're learning about the experiences, you are not actually learning the experience, you are exploring the fundamental principles that were used to achieve the specific results there. And then once you nail down the fundamental principles, you can be able to contextually apply them in other projects to deliver unique project results for that very specific project. I'm very, very impressed. I like that you are able to, like, there's a very good trail of thought. They normally say design is storytelling. So you're telling a story, and you are telling a story through decisions, through actions, through your thought process. So when you embed the design in your thought process other than the software, then the whole thing becomes very easy. You become very versatile. You become a problem solver. And that is what we look for in engineering. So you will allow me to share my screen so that then we get on with the session for today. Um, I am, of course, as I earlier said, I'm going to be using your design because that was our agreement. I once again want to say it's good to see people keep their word, and then this whole exercise will become extremely easy, convenient, and good enough for all of us. And that is for for our success. So I've noted one, two, three things that I think I would like you to probably look at. Number one is the scale. Um, we normally say that for some projects, we normally use a scale. Look at this, a scale of somewhere around 1 is to 500. At least you can be able to see the changes better. You can also try 1 is to 750, and you see at least it's more visible. But then, of course, also depends on you could be short-sighted or you could not. Anyway, that's it. I thought I thought that's something that you can change.
Okay.
Yeah, just for better visibility, so also you don't strain too much to get onto your screen. So today I wanted us to look at one more thing, which is the labels. You remember when you were creating the alignment labels, I told you to use I don't remember where that is. Okay, let me see. Oh, I should select the label itself. Um, and then edit label group. Label that was called, uh, the major, minor, and then geometry point and all of that. The reason for that, I think I explained earlier on. These are the major stations. So there's 000 plus 100, and these ticks represent the minor stations. This is not cast on a stone. You can always modify also again according to the scale and the size of your project. For example, if I select the labels, there's a contextual ribbon that pops on screen. And I'm going to start with the very first one, which is edit label group. So this is a group of labels. You remember there are those stations, there is these markers. There is also these ones that are calling itself transition. This is the start of transition, start of circular curve, then you see this one, start of circular curve one more time, and then start of transition curve. The same thing will repeat itself. I have seen also another small mistake that we need to take care of here, which is a PI, and I know what you did there. And then I know what you did here again. and what you did somewhere here, and probably what you did some other place here. So we are going to correct all of them. Let me start with the labels first. So the label groups or the labels allows us to, identify our design, so that also it's easy to label it, to give information to the readers or to the people who will be interpreting the design. So to modify this, I'm going to escape from the current selection and I'm going to select these labels. So you select the labels. So for example, you can even select the single one here and then you go to edit label group. And in the edit label group, you see these are the major stations that we talked about, these ones. The minor, you can see the intervals is at 100. So depending on the size of your project, you can actually even decide this to be at 50 meters. And then the minor stations, these small ticks, you can decide them to be even at 20. So this is your preference. And I know you know how you mark these parcels or these labels on the changes in actual site. Then the other points are geometry points. So you see these ones, they are called geometry points. Remember, this is geometric design, horizontal alignment. And the geometry points are the same. We said PC, PI, that is point of intersection, point of curvature, point of tangency. And it's also going to label all of that. So that's why we're having geometry points. And you can see the style is perpendicular with a tick. So perpendicular with a tick. That's it. Profile geometry point, of course, you don't need them in horizontal alignment. Anything that is calling itself profile, you don't need profiles in horizontal alignment, basically. I normally like to keep them as clean as they are. So there is the major station, minor station, then there is geometry points, as we have said, and then there are super elevation points. So for that, we can be able to save it. Look at it. You can be able to save as a label set. So I don't want us to save as a label set now because we have 1, 2, 3 other modifications that we're going to be making. So the point that we are making home here is when you're designing any horizontal alignment, the key things that you want to show is the major station, minor stations, geometry points, and then the super elevation points. Then apply and then press OK. So you will notice nothing changes because also it was not displaying the horizontal alignment before. Now, there is this beginning point, and I know you touched it. That's why it looks like this. If you want to restore it to the normal condition, you just hit that. So look at it. You can be able to stretch it actually. It's something that you can do for all labels. This is called drag state. So you can decide to have them, however way you want, something like that. If you want to restore them, there's the dot, a circular dot, and then it resets them too. You just click on it and it resets everything to the normal condition. So even if you did this by mistake, it shouldn't be a big deal anyway. Fantastic. We'll go again to styles. Now let me finish labels first. So we have understood that for the labels. I'm going to go to edit labels again. And I want to go to the major stations. And you notice that there is this under style, there is this label icon, and we can be able to edit the style. So this means we are editing the display. Let me just move this away. We are editing how this 400 looks like. So for example, there is the station, that's the name. There's the content. So the content is the actual label itself. You can select here. And if you select it inside this AutoCAD section, this is more of a display section, and go to format, you can change even the color. So for example, let's say I want to use the color to be cyan, if I want it to be bold, italicized, and all of those things. Then under properties, I can also, uh, modify, decide whether I want the unit in meters or kilometers, the station format that I want, whether it's a decimal, station index, or station format. I can design the rounding off and all of those information and then press OK. And you can see, for example, I've changed the color to be in cyan. Remember again under the same, if you don't like, if before you edit, you must select it inside first, and then, for example, go to format. I can, for example, change the style to, let's say, even Arial, something like that. I think if that is something that you prefer. So what I'm saying is the labels can be modified according to your taste and preference. These are some of the things that you do to improve the appearance of your design. Because a designer is about being a designer is all being about appearance. There is also attachment point, so you can be able to vary. I want you to look at the display. So there was middle center. So if you want it at the middle center, if you wanted all of this, but middle center is always the best. If you feel also the text is too small, you can be able to increase it. So for example, let's make it 300 and you see it becomes better. The other point is you want to offset it a little bit far away from, it goes away from the center line. You can say, for example, I want to offset it to 10, and you can see how it moves a little bit far away. So this is when, for example, we'll be modeling the corridor. Of course, if it stays where it is now, as per the drawing, there will be a lot of overlap. And in any design, you don't want to have any overlap whatsoever. So you can push it a little bit far away. The second thing is, I know you've seen areas where, for example, they are vertical or they are perpendicular to the direction of the alignment. So for example, we can change this to 270 and you see this one changes and it's perpendicular to the direction of the alignment. Remember also there are instances where, for example, you have seen borders and for example, you have seen this one. This one is a common type of border. And just below it, you can be able to change also the color of the border. For example, if you want it to be white, and you can see that is already applied there and then. So that is one way of modifying the labels that you have. And for example, if we do that, apply, and then press OK, you will notice that our labels for the stations have been modified accordingly. So this is also according to your preference and taste, and how you want to present your design. This is one key area to improve on your design as well. The second thing is the alignment style itself. So I'm going to select it, and in the dialog box, we are going to have alignment properties. In the drop down, there is alignment style. So remember, this is the same that you said you could modify during the initial creation of the alignment. And you can also be able to modify the colors. For example, there are people who want the alignment to be, for example, thick. So you can select this. Sorry, you can select one of them. For example, line weight, and then all the way to there, and then you're gonna change the line weight to 0.4. Press OK, and then you're going to apply and press OK. So you just have a little bit of a thick alignment. Remember also on the style, you can be able to modify the line type. Because this is center line, you can use the center, for example, center 2. The difference between center 2 and center 1 is just the spacing. And then press OK, and then also you can be able to modify that as well, just to bring that touch in your design. There's nothing much, and you can see the alignment, of course, has changed. Remember, once you've done your design, there's something that is called set alignment. So from this point, you would like to see where exactly the hinge of your traveled way will be. So in this case, you can select the center line, and then in the center line, there's a large band, and you can be able to create offset alignment. So you just select offset alignment, and this is the dialog box to create the offset alignment. So, for example, if you're designing this road as, for example, 3 lanes or probably 2 lanes on each side, then you can be able to put it 2 here, and then you put 2 here, and then you're going to be having 3.5, and you can have a 3.5 here as well. So that is the width of the 2 respective lanes that you're adding on your road section. The offset alignment style, you can also modify them here. For example, in this case, they are saying it should be white, and probably you can decide them to be green, because you're the one who is choosing, what color is going to be representing what in your design. And then once you do that, we normally don't recommend having labels uh, on your offset alignment. So we just use no labels for this case, and then apply. And we'll notice that our road now has 4 lanes. That is 2 lanes on each side. So we have 1, 2, and then we have 1, 2 on each side. Should you also be having a shoulder and you would want to demonstrate that as well, you can be able to select the alignment, go to offset alignment, and include it accordingly. I don't know if we are good up to that point.
Yeah, I'm okay.
Fantastic. Thank you. I like that. So the second thing is, for example, we can be able to select the outer lane. So let's assume that we, for example, have a bus bay at this point, and we would want to do some widening of the road, which is a common scenario in most of our road projects. So you select the alignment, and of course, as you can see here, there is add widening. So you can be able to add widening, and it will ask you create widening portion as an alignment. So you can say yes or no, but there is no need of you creating it as a new alignment. So you want it to be part of this other alignment, and you're going, for example, to select the start station. For this case, for example, let me say I wanted to start at this very point, and then it is asking me to start the end station. So I'm assuming that it's going to be running for like 500 meters. Of course, that's an assumption. And then it is asking me on an offset width. So that section, how do you offset that section? What is the width of that area? So remember, the concept is always everything is tied to the parent alignment. So the center line is called the parent alignment, and everything is tied to it. So if you are offsetting, you remember this was 3.5, 3.5, that was 7. So you say you need to have a lane bus bay, for example, with 3 meters. So in this case, that would be 10 meters. That is the offset, and then press enter. And what you will notice is already the offset has been created. Once that is created, you will notice that the software is going to give you the option to modify the parameters of your widening section. So for example, the offset here, if you wanted to increase the offset, you can see it there. If you want reduce, you can be able to make it 9. So in this case, the widening is minimal. If you want to modify the start station, so the start station is somewhere here. If you want to modify it, you can be able to modify. Remember, bus bay design are, of course, according to different categories and structures, depending on the volume. Hey, the children. But then you just look at the specifications of our bus bay and all of that. They vary, but of course they are standard ones. That's something that you can check from your road design manual, or just check even online. If you want to increase the range or length, you can be able to increase it or reduce. So for example, let's say I want this to be 300, and you can see the changes are adjusted accordingly. There is the transition parameters. So the transition parameters is quite something, and this is what is happening here. You know, the transition section, that is from this alignment, from the widening, how it is going back to the major road. That is always, there are many ways of transitioning. There are the ones that have linear, and this is where the road tapers directly in a linear section. And in this case, we use a deceleration and diverging or a converging section of 35 meters. That is sufficient enough for the vehicle to move. But you'll notice also other road manuals recommend having a curve, line, and curve. And then the radius for these ones are sometimes very big. So you'll notice, for example, the Kenya Road Design Manual says that the radius for that section should be 40, and then also the radius for this curve should be 40. So in this case, it avoids, you see this section, this area is a curve, and you can see it. This section, the taper section here, the point of contact is a curve, and also the point of contact here getting into this other road is always a curve. So that ensures that it's very, very, very smooth, and the same principle is applied on this other side. Once that is done, you can just close this one, and you are widening, my brother. So that is how widening of roads is done. For example, it's the same thing that we could also do here. If we wanted to do widening at this curve, for example, this one becomes a climbing lane. It's on a hilly section. That is exactly the same thing and the same principle we're going to be using to execute our widening. So if you also want to edit the grips for your transition, you see you can be able to move them, but I don't recommend doing manual edit for the grip here. Just use the offset parameters here. So these offset parameters will make it very easy. I'll repeat that one more time. For you to activate the same offset parameters that we had here, that's, for example, you had already designed this section and you want to modify, you're going to select it, and then you, under contextual ribbon, you go to offset parameters, and then under offset parameters, you can be able to modify. So for example, you see we had not modified this accordingly. So this, the taper in, the transition in, we had not modified it very well. And then this becomes 40. And also, so this one becomes 40. And then we can retain this to be 10 meters. Okay, so that is basically how you get to do it. If you want to retain this to be even 300 or even 500, I'm just showing you how to modify it. That is exactly how it's done, and you make sure that then after that you close, and everything else will be good enough in that very case. So you have your widening, and you can be able to accommodate. So any point that you want to do your widening, you just use the very same principle to achieve widening of your section. I don't know if there's any question up to that point before I move.
Yeah, I have two questions.
Mm-hmm.
And the first question is the road widening. Is it always applicable to the transition and the circular curves? Wherever you have the circular curve and the transition curves, do you always
where we
widen? Hello?
Yes.
I'm asking that wherever we have the transition and the circular curves, that section of the road, do we always have to widen it?
No, 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 no. We do widening when the curve is too tight. So for example, you see your curves here are very, very large. So for example, let's say we don't have sufficient radius for the curve. That's one of the ways to there are two scenarios. The first scenario is the kind of vehicles. So if you're having very large truck, you remember the habit of the vehicle, the rear tire of the large trucks, tracking inside the car. So that is one scenario where we, we do widening for that case. So this means it's from the road survey that was done and it has informed you. And this is, for example, something that will happen a lot in your area of jurisdiction because you're dealing with very, very large tracts. And in such a case, you can be able to do widening. That is, if the radius is very close to the minimum radius. But you see, for our section here, the radius are very large. Any vehicle can be able to navigate. But let's say you are designing for a design speed of 80, and you found that the radius should be around 250, and that is only what you can be able to achieve in your section. So you can be able to widen to accommodate a large track. The same thing also if the radius is below that section. One way of also counteracting the safety issues in that area is to have a very wide section, such that if the vehicle comes, they can be able to maneuver or wander within that road without necessarily losing track.
Okay.
Yeah.
Okay. So the other question is with the standard, the AASHTO, is it applicable to every industry? For instance, I know for our urban routes, the feeder routes and whatever, we can depend on the AASHTO for our design. But
Yes.
when you come to industries like the mining environment, do you still use the AASHTO for those designs? Like especially
Yes.
where I find myself now.
Yes. AASHTO is always the guiding book, eh? But then again, what I normally advise is, for example, when you also need to, it's always also asking about people who have already been in the industry in that area. And there are local manuals that, for example, the government has prescribed for certain areas. We call them the local jurisdictions. So if your government has a local jurisdiction um, that says you should use one, two, three things, then you can ask the people in the industry. And I think that is one of the questions that you'll be asking when you'll be taking office. Uh, or also you can be able to do even your own research and understand what does Ghana say about roads in these areas. One thing that I'm very specific, they change is in the pavement design, because of course in that case they are for industrial, so they are not going to use the usual pavement uh, design manual that we use in the usual road, because you are the kind of trucks that are going to be using your road are very heavy. They are loaded. They are very, very, very loaded. So in such a case, you cannot just use the usual design manual. So please just ask around with your colleagues or check what your local jurisdiction has. Because then this is how people in the local jurisdiction don't think. The local road design manual has more power because that is its area of jurisdiction than the AASHTO. So AASHTO is meant to supplement the gray areas that we have in our local road design manuals. So for example, the reason as to why we refer to the AASHTO standards in Kenya is because our road design manual is as old as 1987, before even I was born. There is a lot of evolution. So AASHTO has a recent one. They published one in 2018. So we want to check them so that we stay up to date, and also even the people who are taking, or the regulators also understand that there is variations that our road design manuals have shortcomings in. Same thing if you go to design intersections, roundabouts, and all of that, there are a lot of shortcomings in our local road design manuals. So we supplement with the AASHTO standards and of course code. Then the first principle is always the local road design manual, because it has power, or it is its area of jurisdiction.
Okay. Thank you.
All right, fantastic. Now, I noted something that I went and asked to correct. The horizontal alignment is good. Actually, what I was doing, I'm deleting these polylines, because now once we have already been able to establish our best alignment, in this case, we just don't need all of these points. These lines that were for the existing route. You can just do away with them, and you are basically left with your road project as it is here, just that channel. Now, I wanted to talk about something because I noticed when you were doing this, you went a PI. This is a point of vertical intersection. Could you possibly remember how you happened to have this? I don't know if that's something you can gather.
Which one is that? The PI.
Mm,
Okay, what I did was in creating the alignments, I did it in bits.
okay.
I did it in bits. So for the straight line, I didn't. Some of them I didn't create. I did it in bits, in sections
Mm,
for a straight
yes,
line. Yes,
yes.
that is what I did.
Okay. I expect, and that's a good way of getting the work done. But then when we look at it in a technical perspective, this brings a disjointed section. So we consider it as a non-continuous. And of course, in road design, the alignment should be very continuous. So yes, the PI helps you to create and achieve the alignment, but you can be able to remove them after you do your design. So you just select the alignment, go to geometry editor, and then you remember the icon here. You can actually even be able to insert one. So for example, let me say I want to insert a PI somewhere like here. So it's a point of intersection, that one, and you see it has been inserted. So this is where I want to, sometimes it's used to force an alignment to pass through a specific point. That's why we use the PI. But in this case, it's very unnecessary. It causes in discontinuity. And of course, if you go away with it, you just go to delete PI, and then I'm going to be deleting all of these that you have. I'm going to delete this one as well. And you can see now the alignment moves just slightly. Uh, I'm going to be deleting these as well, you know, uh, and I'm going to be deleting uh, this one as well. Uh, Let me see. This is good. This is good. This is good. And I'm going to be deleting this one as well. I think, is this a PI? I assume so. I'm going to be deleting that as well. So in that case, you have removed all of those PIs. They are very risky. They are safety hazard in your road. They are only used when you are forcing your road to pass through a point. And that's not something that you want to do a lot of times.
Okay.
So what you did was smart. They help you in in completing your alignment. But then when you are done with them, and then now you are left with adjusting the alignments accordingly, just slowly by slowly using the grip edits. So remember, you can be able also to use these grip edits. It's important to note that when you have your offset alignment, if you move your center line, the offset alignments move with it. They are dynamic. If you modify the parent alignment, also the offset alignment will move with it accordingly. But so far, so good. I like this. This is good progress. I think you understood the assignment. Those are some of the areas that I wanted to polish you on, and then from there we can be able to move forward. Do you have
Okay.
any question?
Not at the moment. I'm okay.
Oh, okay, great. If you have any, please just you can interrupt me. Uh, and then we just make sure that it's done. So you see also the offset that I was telling you about. You offset it. So you can imagine if these changes were just crossed the center line, your design would be looking very chaotic. And that's not something you want to show in your design work. Now, let's go to the next point. And the next point is super elevation modeling. So super elevation is what helps you to improve the safety of your road. It's basically called banking of your road, and it's very easy. It's very easy to calculate. So what do? You select the alignment, and once you select the alignment, first you must go to alignment properties and go to design criteria and make sure that all of these are checked. So once this is checked, you can see, for example, for you as you need to check these and improve it to 6%. You had used 4%. I can see the design speed was set. I want to show you another concept. Remember, there are scenarios where, for example, you can change the design speed. So, for example, the design speed from kilometer 4, um, 4,000, okay, 4 plus 900, it's not 80, but it's supposed to be, for example, 70 or 60. So you can have more than one design speeds in the same project. So that should not be boring you because, for example, if your road is passing through urban areas, passing through some deserted areas and all of that, the speed cannot be consistent in through the entire section. So you apply, and then press OK. Now, once you do that, you can be able to calculate super elevation. I'll repeat, you just select the alignment. And once you select the alignment in the contextual ribbon, you can be able to go to geometry editor. Sorry, not geometry editor. You can go to super elevation here. So select super elevation, and then you go to calculate or edit super elevation. The software is going to tell you there is no super elevation data that is existing. So you will tell it to calculate super elevation now. So calculate the super elevation first, you need to select the roadway type. So for example, this time is undivided crowned road. This is how it looks like, divided planar, divided crowned, and divided planar with median. So I think like our section is this type. The pivot point is the center line. And then you press next. You're going to be having, for example, in our case, we have 2 lanes on the left and we have 2 lanes on the right. So I'm going to change 2 to 2 lanes. Then the width of your lane, this is going to be 3.5. And then also the slope. I think the slope varies from country to country. You can be able to use a negative 2.5 and then go next. There is no super elevation that is calculated on the inch of shoulders. So you just select that. You also don't calculate super elevation inside median focus. You just leave it be. And then you go to next. This is about attainment. So you have to assign the specific manual or people that you have to select the specific attainment method for super elevation. So you remember when we were setting the design criteria, we of course selected the 2016 AASHTO Green Book. The 2018, there's the 2018, there's the 2015. You can see this is for roundabout. There's the 2018 metric, and then get to open. So that is what is going to be used. There's the percentage of super elevation that is happening on the tangent. That is always 3/4, or 2 banks rather, 66.67. There is surplus, percentage of surplus, or rather spiral for spiral curve. super elevation along spirals, we give it 100%. So all the super elevation should not go to straight section. It is only accommodated within the spiral curve. Once you do that, you're gonna finish, and then the software is going to calculate the super elevation for you. So once super elevation has been calculated, you can see, for example, there is the level crown. You can see these labels have been introduced, and we have the normal, where the camber are just sloping in the opposite direction. There is the second one, which we call, let me just make sure that we have something here to refer. There is the level crown. So in the level crown, I don't know, I don't know where you are. There is the big full super. You can see the mark. So the big full super is in the circular section itself from this point all the way to this other point. So that's how you identify the big full super section. And yeah, that's it. Any question up to this point?
No, I'm okay.
Ah, great. I like that. So this super elevation report, you can be able to explore it. So for example, you can see a super elevation for this section is going all the way to 4.40%, and 2.5, and all of this. So it looks like I have not met any, or I have not been able to violate any Miraggio rules or the manual specification rules, and therefore my design will be good. That does not mean that it is practical. So you notice that there are some small errors that you can be able to fix going forward. So if you need to export this report, you can go to this icon, and then you're gonna be able to export directly um, to your folder. Okay, great. So that is exported, and you can be able to open it in Excel. And in that case, you have already calculated your super elevation. So in super elevation, the key things that you need to note is number one, there is no calculation of super elevation on shoulders or in way bridges. You get to walk and see. Okay, great. So I think up to that point, everything is all. Let me introduce vertical alignment design. And in vertical alignment design, it's basically the same principles that we used in horizontal alignment. But in this case now, I'm going to explain them just for you to make sure that, yes, please. Oh, sorry. I thought you were speaking. Um, but anyway, so I'm going to introduce vertical alignment. We get to introduce it, do it, and then we will wrap it up. Um, so when we're talking about vertical alignment design, the first thing that people talk about is sight distances. And these are fundamentally very important because if you design a road then and you don't provide sufficient sight distances, then this will be a killer road. So imagine this vehicle that is moving here. If the driver has not provided at least 40 meters it becomes very difficult. This vehicle is going to automatically hit those curves. But if we had provided a longer distance or a shorter distance, then the vehicle cannot be able to hit the cutoff. So that is the effect of insufficient distance. When designing vertical alignment, we consider two things. One, these are the major controls. Number one is the minimum sight distance. So this is what the driver can be able to see ahead. The other one is drainage, and the other one is comfort of vehicle and participants. So the most basic one is the stopping sight distance. Like you can't get away with that. No design can be implemented without you giving them the assurance that so and so is very able to do 1, 2, 3, 4. That is very important. So these are some of the things that we look at. Vehicle speed. We want to know what are. These are some of the things that influence design. Vehicle speed. So if the vehicle design speed is very high, even the mountainous section, you will need to lower it very much so that you achieve the same driving experience. The second thing is drainage. The other one is the economy of transport. So we normally say that it's a mix of a trade-off. And therefore, in such a case, you'll be able to trade off some aspects for the other. For example, you can be able to say, I'm trading off construction cost for road safety. And then you prepare a report giving that report. So great. So up to that point, the design elements, these are just two types of curves. Or rather, we only have two design elements in horizontal alignment, in vertical alignment, and that is a crest curve and the straight grade. So if you look at it keenly, you will notice that the straight grade is just the same that we talked about. But in this case, we are calling it entrance grade and exit grade. So the entrance grade is the grade that is getting into the curve, and the exit grade is what is getting out of the curve. So the vertical curves are meant to provide a smooth transition from one grade to another. And a typical example of you visualizing the vertical alignment is you thinking yourself as the person who is sitting on a drain. So just sit on the side of the road where there is a drain and the road is a little bit above you. So just see a line that looks like this, that is either going up or down, straight up or down, straight up or down. And that is basically what it is, my amazing engineer. And we want to design curves that will allow us now to transition between up and down, up and down, up and down. These curves can be in two terms. Either there is what we call a crest curve or a sag curve. So a crest curve is where, this one is a convex, and then in a sag curve, it's a concave. Anyway, in a crest curve, you're going uphill. In a sag curve, you're going downhill. Let's not complicate things. Then on the other side, there is, of course, the geometric points are still there. There is the PVC, PVI, and PVT. PVC, PVI, PVT. But then there is something else here that is calling itself the length of a sag curve. So we need to know the length of a crest curve here. So there's the length, PVC, PVT, exit grade. So this will be percentage because it's a gradient. Okay, it's a gradient. And then here we'll be talking about one other aspect. So this is just mathematics for the vertical curves, which I don't think are necessary. These ones are not necessary. But then one thing that is necessary is This crest curve and sag curve, they must meet some criteria. And we have a value that is called parameter K. And the parameter K is what allows or ensures that the site distances that we have, the site distances that we have on any given curve are sufficient and drivers are able to see ahead. So should you not meet these ones, it's very difficult for you to, for the road, for the safety of the road. So for example, you can see with a design speed of 80, which we are using, we need to use a stopping sight distance of, or we need to use a parameter K of 30 for us to achieve the right stopping sight distance. You need to achieve this K of 30 for you to have the sufficient stopping sight distance. Remember also when we are looking at obstacles on the road, and what is this stopping sight distance? It's the distance that a driver needs for them to stop a vehicle safely when they see an obstacle. So let's say you are driving down a road and you have met some cows crossing the road. So what distance do you need? You need some distance for you to stop safely. If the design engineer did not incorporate that, then you will never stop. You will always cause accidents, even if the object is just right there, or even if you see it from unless you see it from very far, and then you start slowing down. Then the beauty of this stopping sight distance, if you provide for it, in case you call, or rather in case you see the vehicle, even, or you see an obstacle, even at just within a reasonable distance, you'll be able to stop. So this is the minimum for K stopping sight distance, and then this is the K for passing sight distance for you to be able to overtake. And you note this down, this parameter. For 80 kilometers per hour, we're going to be needing 30 here. We're going to be needing 30 for that case. So this is the AASHTO specs. Again, I would like you to just check with your local road design manuals in Ghana, in whatever that you're using. I think they still have the same parameters, very close to this one, because they have all derived their manuals from the AASHTO standards. So in this case, this is you can see the AASHTO one is more optimized. So instead of 30, they are recommending us to use 26. So that is the main one. But then there is the other second option. Remember, when we were looking at this one, we said there is the K parameter that controls the stopping sight distance within the curve. And then there is also the length of the curve. So if the length is too short, remember these convex will be too sharp and therefore the drivers cannot be able to see. And it will also, the gradient will be too steep and motorists cannot be able to climb up here. Same thing also happens here. If this length is too short, then this becomes a depression and vehicles cannot be able to transition, from this point to the other point. It's basically as simple as that. So those parameters that we are calling K values, they help us to make sure that does not happen. The minimum radius or the minimum length of curve is also tied to the design speed. And you can see, for example, for a design speed of 80, you need you need a length of 140. Actually, this is very easy. We always say the length of the curve is equal to 2 times the design speed. That is the rule of the thumb. Length of LVC, it's called length of vertical curve, is equal to 2 times the design speed. 2VD. LVC is equal to 2VD. It's 2 times the design speed. So note that down. It's a rule of the thumb. It applies all over. Sorry. Sorry about that. My boss was texting me here, and I had to reply. Unfortunately, I left my phone open, so I've opened the message. So 2VD, if you look at this trend, that is how you can be safe. 40, 2VD, 40 times 80, 2VD, 60, 2VD. You know, it's within. If you use 2VD, 2 times the design speed, you will always be safe. You will be on the upper end of even the parameters that are given here. So that is a rule of thumb. That's a rule of the thumb that will always make sure that you adhere to the safety. Now let's go to sag curve. Now that was the design of vertical curves, by the way. Note them down. For crest curve, the K, when the obstacle that we are considering is at a height of 0.6, the K value at a design speed of 80 is supposed to be 30. All of these are in the design manual that I gave to you. If you go now LVC, it should also be 2VD. That is for crest curve. Now, sag curve represent a completely different problem. Why? In sag curve, what we design for 2 things: comfort, there is the comfort criterion. And then after the comfort criterion, we also design for headlight glare. So you've seen at night when you're driving downhill, there is always a high probability of the driver coming in the opposite direction, doing the thing for you, and you can't see nothing. That's a challenge. It's a problem. That's a problem. So for you as a design engineer, you have that option to either design for comfort or design for end-light distance. And there's still the parameter is K. So the 80, you can see for comfort is 16, it's lower. But if you want to account for end-light distance, such that if the driver is even far away on the other side, the end-light distance cannot be able to get to where you are. And this is 32. So you can note these 2 down so that we can compare them as well. There's also the gradient. So we control the gradient. The gradient also, we said that it controls the drainage of transport. Of course, it's pegged to the terrain. So if the terrain is too steep, then there is an issue with drainage. Then there's nothing you can do because terrain is supreme. If you want to do a lot of excavations, then it means you need to invest a lot of money to make sure that you cut away material to probably achieve some gradient. And there's something that is called economy of transport. You will notice that when you're driving uphill, you will consume a lot of fuel because the vehicles requires a lot of torque. So in such a case, that's why you find international trunk roads or major roads. The government would rather invest in a lot of earthworks to cut and minimize the slope as much as possible. Sometimes even have tunnels, sometimes even have underpasses to make sure that the transport of the economy is very low to achieve these slopes that we are having here. So any design must be able to achieve this slope. You see, for example, if you are designing a super fast highway, at a design speed of 140. You see, that one cannot be designed in mountainous area. You can see that clearly. Like it's completely unfeasible. That is why then they even, like for example, the Chinese in their mountainous areas, they decide to have overpass or flyovers, expressways. And the beauty of expressways is the slope is always between 3% actually. So in such a scenario, you avoid all of the other work. So you do the cost benefit analysis, and you notice instead of you just cutting all of that ground just to achieve that, you would rather raise some bridge piers, and then after that you have an overpass or a precast bridge or whatever to get traffic to the other side. So those are some of the concepts that are looked into when it comes to design. You remember also when we were talking about the surface analysis, you remember we got some values between 3, I don't know, 4, 5%. Then there is this table. So you can be able to tell whether your terrain is mountainous, rolling, flat, escarpment, or in an urban setting. And look at this note here. On freeways, a maximum gradient should not exceed 4%. So that's the maximum on a freeway. On an expressway, it's actually 3%. That's the maximum. You can see we have desirable and absolute. So this is what we desire. But in case we don't have that, then this is the maximum that you can be able to accommodate. So these are all principles, once you combine them together, that is what helps you to come up with a very good vertical alignment. The flat, you will be able to know what terrain you are in, what design speed you are, what are the key values, what is the length of your vertical curves, and then from that point, you can be able to proceed and do your design. I don't know whether you have any questions to that point. Just understanding the theory from a.
It's okay.
And I noticed something. Have you noticed you inverted your points?
So that is what I was talking about in the challenge that I faced.
The damage is done.
Oh, but I can still redo it.
Yeah, you can redo, but up to this point, the damage is done. There's nothing you can do.
Oh, I can work on it. It won't take me much time.
Yeah, it's something easy. It will help you actually understand them better. So please take note of that.
But how come? Because it's just the same coordinates you gave me. I didn't edit anything. I didn't change anything.
No, the organization, you see, the northings are always bigger than the easting. So then the northing is the one that should be the 977534. And then the easting is the one with 408, something like that.
Okay, so
I don't know whether you understand.
Yeah, I understand.
Yeah, okay. Thank you. So then how do we do vertical alignment? I want us to do that quickly because that's basically what you're going to be doing, working. It's easy. So you just go to profile and you create surface profile. So once you go to create surface profile, there's this simple dialog box, and you're going to select the main road center line. And then you're only going to select the existing route on this other right side and then add. And that's it. And then you tell it to draw in profile view. And then once it comes to the profile view, it will have the alignment, but you cannot change. You can change it, but there is no need because we selected the right alignment. You don't have even to rename it here, and you just press next. The stations, it picks automatically from your horizontal alignment, so we retain the 5 kilometers. And then there is elevations. This is the profile view height. it extracts them from the elevations of your road project. We remain automatic. And then you can be able to see the existing route is the profile that will be displayed. And then there is data bands. So in the data bands, one more time, don't worry, just retain the default. I'm going to be taking you through that slowly. And then we go to next, profile hatching, just retain it as it is, and then create profile view. So pick some place far away from these, and you're going to be having something like this. So this is how your design actually looks. This is how your terrain, this is how your ground looks like. This is how your ground looks like. So you will see these point where there is nothing being shown. What that tells you is, let me go to the surface. I want to have the sorry. I want to go to properties and I want to display it. Oh, it just frozen. Huh? So I want us to go to this station, and you will notice where this is. It's around kilometer what? This is kilometer 3 plus 766. Kilometer 3 plus 7, 3, 3, 7. So you see here, it's at kilometer 3, 8, 353. So it's here. You can see the horizon, the alignment is somehow far away from your surface. You see that? The alignment is away from your surface. The alignment is away, it's outside the surface. So when the software tries to extract elevations for this point where the alignment is passing through, then it doesn't have any information. And in such a case, then you will always find that there's a gap in your road section. So how can that be corrected? Of course, the surveyors can be able to go back on site and help you with 1, 2, 3 things, or you can actually even get to, just move the alignment just a little bit, just adjust it a little bit to the inside, and then of course that error will be eliminated, and somehow you can be able to have your data. In a contextual ribbon, this is also again where when we talked about data collection. So you will notice that the surveyors end up very big spacing between these ones. I always recommend spacing of 20 meters, 20, 20, and even 20, 20, 20 meters is reasonable. But in this case, you can see they picked some point here. This is kilometer 3 plus 600. They picked some other at kilometer 3 plus 8. Those are like 900, 800. Those are like 700 meters. Then from 900 all the way to kilometer 4 plus 300. So this is not good practice. And that's why we're having those errors with the surface. You will notice where the surveyor was seriously picking points at close intervals, you will not find those mistakes and errors. So that is something. And you see when we have already moved the alignment there, then that error has been corrected. So please also, as you're working with your survey, it's good to give them instructions to make sure that they understand that they need to, they need to do something. They need to pick at close intervals. So I want you to note that, please. I really don't like people who get too fret. This is just but a graph paper. It's a digital graph paper. So there's nothing. It has an x-axis and it has a y-axis. X-axis has the elevations. X-axis has the stations. And then the y-axis here has all the elevations. You can adjust, just select it, go to properties. So for example, on elevations, we could use user specified, and we can reduce this, for example, to 680, and then increase this probably to 780, and then press OK. Look at that. The graph becomes bigger, and we can be able now to have a good view of our road. The second thing is we can select a profile and clip it such that it's easy for us to see the OGL. So I'm going to select it. Under profile views, there's a drop down, and I will go to edit profile view style. And in this case, I can go to the grid, and I'm going to clip those elements. Look at that. So when I click those ones, I can be able to have my road as it is. See, go to profile properties, profile view style, and then I can be able actually to even clip all of this just to make sure everything is clipped. So in this case, I have my road as it should look like. The second thing is we can be able to change the scale still under edit profile view style graph. And for example, you can change the scale from 1:100 to 1:200. And you see that becomes flatter. So that even as we make decisions, it's easy for you to understand how your terrain actually looks like. So now we have a better perspective. This looks like a sag curve. This is a valley. Looks like there's a culvert or a box culvert that was here. Looks like there's another one here. Looks like there's another one somewhere here. Looks like there's another one here. Looks like you have another drainage here, and looks like you may need to have another drainage here. So it's basically like you are looking at the entire stretch of your road in a computer. There's nothing much. There's nothing else. It's nothing serious. So to design our vertical profile where we want our road to pass through, we're gonna go to profile and then create profile by layout. Create profile by layout. We select the profile view, and then we are going to call it FRL, meaning formation road level. Then press OK. It is the same dialog box or the same toolbox that we end in horizontal alignment, but in this case, it is used for vertical alignment. So we have the first section, draw tangents. You remember the other one was called draw tangents as well. So we say draw tangent, and the first tangent must always start at the very origin. And then you will again estimate where you see your straight section and following the OGL as closely as possible. And that's it. And then press enter. And it will give labels. It will give you the slope. It will give you the break and the elevation. You'll do the same for the other second section. So I approximate this is going to start here and move all the way, I don't know, to somewhere like there. And then press enter. And it will give me the slope. And remember the slope here, I can raise it a little bit because I see it is, we said that it should be greater than 0.5. Now this one is at least 0.05, something like that. So this is at least good enough. Remember this section, you cannot be able to cut in a fill or fill in a cut. You try to fill in a cut and cut. You try to fill in a sag and cut in a crest. So we need to connect with a curve here. So I'm gonna go into where there is a curve. The vertical curve is defined by parabolic equation. So I'll go to free vertical curve. Free vertical curve, select that is the first entity, and then the second entity. Look at the dialog box. It is asking us for the curve length. We said curve length is equal to 2VD, 2 times the design speed. So in this case, we can just say 160 for a start and then press enter. And we have our curve. It's the easiest thing you will ever do in this world, my friend. This is the easiest thing you'll ever do. And then after doing that, you can still do the Lord's work again. Go to this one will be called now the profile grid view. And you can be able, for example, to edit even the curve length if you want to make it 200. If you can see the K value. Once you give the curve length, it populates the K value naturally for you. The bigger the K value, the more the gentle the slope or, the curve here, and then that looks great. You're going to be doing the same thing even for this other side. I mean, you gauge that and you know that your straight section will be probably somewhere up to here and you're done. And then you will have this one. You select this first point and then you select the second point, the second entity. Remember, it should be actually, it should be a little bit above the OGL so that you can select it appropriately. So select that first entity, and you're going to be having the second entity here. So instead of using the curve length, we're going to be using K value. So I'm going to select the K value. Remember the K value for crest curve, we said it's the minimum was supposed to be 30. So in this case, you can use that 30 first and then press enter again, and the curve is here. So this curve is very small and it will give the impression of a hump. So we need to increase the K value. We're going to come here, and then in this K value that we have given of 30, looks like we're going to be needing something like even 120. You see, it's becoming something. You can also increase it again to even the curve length, probably even to 300. Because also, think of it in the perspective of vehicles will be driving through this section. So they need to have a more gentle slope here for the vehicles to be able to drive through the section appropriately. So you need a slope, you need a proper slope here. You need a proper slope, you need a proper slope. So that's why we said also this should be a cut. So you just try to make sure that it is not a fill. So you see in this section, it justifies the rationale that you need to fill this section. It's just like you're leveling your home. You need to fill this area, but in such a hill you cut. So the same thing would be, you need to cut here, you need to fill all of those things. And that is exactly what you're going to be doing in this task for today. The easiest thing that you'll ever do in your life. Let me know whether you have any questions, and then we can respond and call it a day.
I'm okay.
You are okay?
Yeah. I'm okay.
I like that. You're a smart guy. So thank you. I'm gonna be sending this. Please also let me show you something just before we break. They are short videos, so you should not struggle too much, my brother. That is why I added you in this Alpha X group. You can go, for example, to this is the main channel. I added you, right? Did I?
Yes, I'm part of the group.
Yes, so you just come to the search function and then you can say, for example, profile view. Aha. So you can see these are the videos that I recorded for them. Create profile from surface. Design simple crest curves with design requirements, what we are talking about today. Optimizing profile view, what we've just modified. And then there is personalizing label sets, and then you will be good. I would specifically ask you to watch this video. This video, can you see this?
Yeah.
Technical design of vertical profiles. This is a recap of everything that we have talked today. So it will reinforce the same knowledge that you have.
Okay.
All right. Thank you. Thank you. So we meet when on Friday?
Friday?
Yes, we meet on Friday. Please make sure
Yeah.
that you have gotten to where I am.
Sure, no problem.
All right. Thank you. Thank you, engineer. It's a pleasure. I am downloading the video and then share with you right after when it's
All
ready.
right. Thank you so much. Okay. All right. Thank you.
All right. Thank you. So make sure, remember also you prepare for your presentation. You're going to be making presentations every day.
Okay. All right.
All right. Thank you. Thank you,
Sure.
sir.
Okay. Thank you too. Bye.
Bye-bye.